21.5, balancing using the half reaction method. And this is sample problem number 9 in your book. In a water solution with an acid pH, the NO3H ion will react with I2 to produce the iodate ion IO3- and NO2. Now, when you're doing half reaction method, you want to break this into two different reactions. In other words, we're going to do half the reaction at one time, half the other one. So we'll do the redox and then the oxidation. So first thing you have to do is determine which one's going through oxidation and which one's going through reduction. So you have to go through and determine your oxidation numbers. So I know that iodine is going to be 0. I know that oxygen in all of these cases is going to be -2 because none of them are peroxides. And then when you calculate this, remember this will have to add up to a -1. So in this case, your nitrogen is going to end up being a +5. Same thing over here. Make sure that it adds up to -1 when you're calculating your iodine. And your iodine ion will have an apparent charge of 5+. And then do the same thing here, but since this doesn't have a charge, this would have to add up to 0. That gives nitrogen a +4. Okay. All right, so from there, what does that tell us? It tells us that our reduction reaction is your NO3- going to NO2. And our oxidation reaction is going to be I2 going over to IO3-. First step that you're going to take, well, actually second. First step is dividing it into the two reactions, the two half reactions. Second, you're going to balance the atoms that are being oxidized or reduced. Here you have nitrogen, and there's just one, and over here is nitrogen and just one. So those are balanced, so that's good. If we go down to iodine, here we have 2 iodines, but here we only have 1. So we need to balance that first, so I'm going to put a 2 out in front. Next, we need to balance our oxygens by adding water. So I have 3 oxygens here, 2 here, so I'm going to add water. When I add water, that will give me a total of 3 oxygens, just like on the other side. So my oxygens are balanced there. Now coming down here, I have a total of 6 oxygens down here. So I'm going to have to add 6 waters on this side. All right, next. Now I've introduced hydrogens, so I'm going to have to balance my hydrogens. Now because it's acidic, we're going to balance the hydrogens with H+, your H+ ions. So here we have 2 hydrogens, so we are now going to add 2 hydrogen ions on that side. For this one, we now have 12 hydrogens on this side, so I'm going to have to add 12 hydrogen ions on that side. Okay. That's the step that you follow when it's acidic. It's slightly different when you do basic. All right, next, we have an issue with our charges. Okay, the charge on your reactant side should equal the charge on the product side, and we don't have that going on right here. Over on this side, it adds up to 0. On this side, you've got a 2+ and a 1-. That does not add up to 0. Okay. This is reduction, so this means it has to gain electrons. So we're going to add electrons to this side to make that charge 0. In this case, I only need to add 1. So I'm adding 1 electron to that side. All right. Down here, this side adds up to 0. This side, you've got 12+ here, and you have a 2- here. Now this is oxidation, so that means it loses electrons, and so we have to add electrons to this side to make this add up to 0. So that looks like we're going to have to add 10 electrons. that makes it add up to 0. Now, with oxidation and reduction, they always go hand in hand. One can't occur without the other. So if we're losing one electron, something has to gain one electron. So in these half reactions, the same thing has to be true. We can see here that this is losing 10 electrons, which means somewhere something has to pick up 10 electrons. And right now, this is only picking up 1 electron. So that means we're going to have to multiply to make them equal. So I'm going to have to take this whole reaction and multiply it by 10 to get 10 electrons so that the number of electrons gained and lost are equal. So now I'm going to rewrite this equation down here and distribute the 10. So I'm going to have 10 electrons plus 10 nitrate ions plus 20 hydrogen ions, and it's going to produce 10 nitrogen dioxides and 10 waters. Okay. Next, we are to add these together to get our answer. But as we're adding these together, we are going to simplify. So you're going to look for things that are similar on both sides and simplify wherever you can. The most obvious one is the 10 electrons. You've got 10 electrons on each side. Those are going to cancel out. Okay. Look for anything else in common. You notice we've got water on both sides. You've got 6 waters here, 10 waters here. That means all of these will cancel, and this will be reduced to 4 waters. Then we've got our hydrogens. You've got 12 hydrogens here, and you've got 20 here, so that's going to leave us with a total of 8. Then we add those together, and we will have our answer. We will have our balanced equation. So I have I2 plus 10 NO3 minus plus H plus is going to yield 2 IO3 minus plus 10 NO2 plus 4 waters. Got to squeeze that in. Didn't leave enough room. Okay. And that is our answer. That's how you do balancing using the half reaction method. Now sometimes our equation won't have ions. They'll have something out in front. And so you might have to break it down a little bit more. But most of our practice problems are already just involve the ions that are going through oxidation and reduction. And so you follow those steps when you're doing a reaction that is occurring in an acidic solution. Now if you're doing it in a basic solution, the one step that changes is when you're balancing your oxygens and your hydrogens. Okay? Instead of balancing your oxygens with water, you're going to balance O using water. OH minus, sorry about that. And then you're going to balance your hydrogens using the water. There we go. Okay. That's a little bit different. When it was acidic, up above, when we were balancing the oxygen, we were using water. And then when we wanted to then balance the hydrogen, we started using the H+. Okay? But that's the only thing that's going to be different in all of these. All right? That's how you balance using half reactions.